What's up, everybody? How you doing? How you doing? How you doing? Welcome back to the YouTube channel. It's me, Mr. Richardson, coming at you live through the power of the internet, and we're going to continue talking about probabilities today in this probability series. And today we're going to talk about conditional probabilities using symbols, or what's known as symbolic probability. If you're just here, make sure you jam that subscribe button and make sure you like, comment, all those things. Helps the channel pop up for other people that may want to learn mathematics that may not know me IRL. Anyways, let's jump right into it. Today we are going to be using symbolic probabilities, which are just symbols. Us mathematicians are lazy. We like symbols for operations and things. It's no different with probability. And symbolic probability is just used to use symbols where we'd otherwise maybe use a two-way table or words for. You have this upside down U looking thing, which is for intersection or for the word and. You have the U, which is for union, or if you see the word or, like events A or B happen. And then you have this dash that kind of looks like the letter L, like maybe a lowercase l, and that means given that. And this is one of the ones that we're going to use for conditions. We're not going to use the union notation today, but we will use this notation for conditional or given that, and we will use the intersection or and notation. So here's the conditional probability formula we're going to use today, which works for all events. It says the probability of event A, and here's that new symbol right here, given event B, well, that just equals the probability of events A and B divided by the probability of event B. So there I have it for you. That's a conditional probability formula for given. Now what's very important for this formula is whichever one comes after the given symbol, so given B, B is the condition here, that's which one goes on the bottom of the formula. These two match. That is very, very important. So for instance, if I wanted to do the probability of event B given event A, that would look very different actually, and I happen to write it down here for you, but that would look like this. So notice that the probability of B given A is not the same formula as A given B. In that case, because it's given A, we're going to put that down in the denominator there when we do the formula. So something to keep your eye on. Let's jump right into an example to kind of give this some meaning and some context. First example says this: Mr. Richardson always tries his best to be on time for work when he teaches. Sometimes it just gets difficult if the train he takes in the morning is delayed. The probability that Mr. Richardson's train will be delayed is 0.12 or 12%. The probability that Mr. Richardson will be late to work is 0.11 or 11%. And the probability that Mr. Richardson's train will be delayed and he will be late to work is 0.08 or 8%. Find the probability that, is that a typo? Find the probability that Mr. Richardson is late to work given that his train was delayed. And we're going to round our answer to the nearest thousandth. First thing I want to do when I look at this formula, see what do they want us to find, because that's going to clue us into the formula. And here it says find the probability that Mr. Richardson is late given that his train was delayed. So what I want to find here is the probability of late given delayed. And notice this is different from putting these in the opposite spots. That would be delayed. That's the probability that my train was delayed given I'm late, which is not what I want to find. Once I have this, I can begin to write my probability formula, and we're going to use the conditional probability that I shared on the last slide, which looks like this. The probability of event A given event B equals the probability of events A and B divided by the probability of B. Well, the order matters, and I tried to color code this for you, but if I translate this formula, everywhere you see this red letter A, I'm going to write late. And everywhere you see this blue letter B for event B, I'm going to write delayed. When I translate it, it looks like this. Now I just have to fill in some information. Let's go back through the problem and see what they gave me. As I read the problem, the first thing it says that I'm going to be late to work 11% of the time, or 0.11. So I can just write that down. The probability that I'm late is 0.11. I read it and it says the probability that my train is delayed is 0.12 or 12%. So I can write that down. And finally, it says the probability that Mr. Richardson's train will be delayed and he will be late for work is 0.08. So that's late and delayed. That's this right here. And I like to write them all as decimals. Sometimes in these problems, some of the information is extra. We don't need it. And what you're seeing here is we actually don't need the probability that I'm late for work. In order to answer this question, we only need to know the intersection, or the probability of me being late and delayed, and the probability of delayed. So in order to do this, I'm just going to plug that in my numerator. I am going to write 0.08. In my denominator, I'm going to write the probability I'm delayed, which is 0.12. And when I divide these here, I'm going to get this decimal. And here it said, don't make it a percent. They said leave it as a decimal, but round it to the nearest thousandth. So I look here, 10th, 100th, 1000th. That last 6 is the 1000th digit. And I decide, should I round it up or keep it the same based on the 6 that follows? And if you said round it up, you would be correct. That answer there is going to be about 67% of the time, or 66.7% of the time, meaning that given my train is delayed, that's how likely it is that I will be late to work. Hopefully you're getting the hang of it. Let's try another example. This one here says the guidance department has reported that out of the senior class, 2.3% are members of the anime club, and we'll use that as A. 8.6% are enrolled in statistics, we'll label that S, and 1.9% of students are in both anime club and statistics. Determine the probability of S given A to the nearest tenth of a percent. So I want to know what is the probability that a student is in statistics given that they're in the anime club. So first thing I like to do is figure out what we want to find, and here we want to find S given A, so I'm going to write that down. I want to find S given A, or what's the probability a student is in statistics given they're in the anime club. Now why this is important to start with this is it's going to indicate our formula. Our formula is different if I had what's the probability a student was in anime given statistics is different than what we have, which is statistics given anime. So those are different things there. And all I have to do is replace. Everywhere there's a red A, I'm going to replace it with S for statistics. Everywhere there's a blue B, I'm going to replace it with A for anime. So I just translate there. Now I go through the formula, see what they gave us. Well, the first thing they said here is that 2.3% of the students are in the anime club. So I can write the probability of A is 2.3%. They said 8.6% are enrolled in statistics. So I can write the probability of S is 8.6. And then they said 1.9% are in both. Here I can write the probability of S and A equals 1.9%. When it comes to and or intersection, it actually doesn't matter which order you put them in. It's unlike conditional probability where that order really matters. Now what we're going to do is plug in. Well, I know what the probability of statistics and anime is. That is 1.9%, which I'm going to write as a decimal in my formula. I always plug in decimals. The probability of anime, I know what that is. That's 2.3%, which I can also write as a decimal, 0.023. And now all I simply do is divide. When I do that, I get this as a decimal, but they want it to the nearest tenth of a percent. So I should multiply by 100 to start. Now it's looking like a percent. So maybe I'll actually put a percent sign there. That would be nice. And it said the nearest tenth of a percent. So here this 6 is the 10th digit. I look at the 0 to see if I should round the 6 up to a 7 or keep it the same. In this case, the 0 indicates to keep it the same. So the answer is 82.6% is the probability that a student would be in statistics given they're in the anime club. Very cool. Let's jump into another example. Here in problem 2, we have the probability a student has had Mr. Lilla as a teacher before is 0.3 or 30%. The probability a student has had Mr. Zahn as a teacher before is 0.61 or 61%. If the probability that a student has had both Mr. Zahn and Mr. Lilla is 24.4%, Find the probability that a student has had Mr. Lilla as a teacher, given that they have had Mr. Zahn. Round your answer to the nearest percent. Same thing we did before. First thing is figure out what we want here. We want probability the student has had Mr. Lilla, given they had Mr. Zahn. So it's going to be Lilla given Zahn. That's what we want. Lilla given Zahn. Well, of course, when we get to the formula, each of these pieces, the order certainly matters. And if A given B looks like this, that means Zahn is going to stand for the B, meaning Zahn is going to be the probability that goes in the denominator. And everywhere there's an A, we will write Lilla. So I'm going to translate here, and it now looks like this. As you start to work through some of these problems, maybe you're getting good enough where you can get directly from what you want to the translation, and you can skip kind of writing down the formula. Let's go through and see what they gave us. They said the probability the student has had Mr. Lilla is 30% or 0.3. So I'm going to write that. Probability of Lilla equals 0.3. Probability the student has had Mr. Zahn is 0.61. I'm going to write probability of Zahn as 0.61. And the probability that they had both, which is Zahn and Lilla, the intersection, is 24.4%. Now this here is going to be problematic here that they gave me 24.4% because I can't use these formulas with some decimal representations and some of these numbers represented as percents. So when I plug them in, I'm always going to plug in decimals so I don't run into that problem. Well, here I want to find the probability of Lilla given Zahn. So I'm going to set it up like this. The probability of the intersection, or when both of them happen, is 24.4%, which I'll write as 0.244. And divided by the probability of Zahn is 0.61. When I divide these, I get a nice 0.4. That worked out pretty great. And of course, I need to round this to the nearest percent. So I am going to multiply by 100. And when I do that, I get 40%. The probability that a student has had Lilla as a teacher, given they have had Zahn as a teacher, is 40%. Very cool. Let's do 2 more examples. Moving on to problem 3. Problem 3 says the guidance department has reported that of the senior class, 70% are enrolled in Algebra 2, 61% are enrolled in AP Stats, and the probability that a student is enrolled in Algebra 2, given they are in Stats, is 80%. Find the probability that a student is in Algebra 2 and Statistics. Round your answer to the nearest percent. Very cool, very cool, very cool. First thing we want to do is figure out what we want to find. Here I want to find the probability that a student is in Algebra 2 and Statistics. Well, wait a minute. This is actually very different from all the other examples we've done. In all the other examples, we were looking for A given B. Now, actually, we're looking for the and part. Well, it's not too different. If I think about it, I'm going to have this formula here. And I'm just going to be solving for the numerator here. That's all. I'm going to be solving for the intersection. And hopefully when I do this, I'm given the denominator, and I'm given this piece over here, the conditional, the one that has given, because without those 2 pieces, I'm not going to be able to solve for the numerator or the intersection. Let's go through and see what they gave us. They said that 70% are in Algebra 2. So the probability a student is in Algebra 2 is 70%. They said that the probability a student is enrolled in Statistics is 61%. And finally said the probability the student is enrolled in Algebra 2, given they are in Statistics, is 80%. So that's like A2 given Stats is 80%, like so. Now when I go to write the formula, I have 2 options to write this formula, A given B. I can either write it as Algebra 2 given Stats, or Stats given Algebra 2. And in this case, I'm going to stick with the one they gave us because I do want to plug in, and I can't plug in Stats given Algebra 2 because I don't know that. I'm only going to be able to plug in Algebra 2 given Stats. So everywhere there's a red A, I'm going to write Algebra 2 because that's what I have here. And everywhere there's a B, I'm going to write Statistics there. And when I translate it, it looks like this. It's a beautiful thing. Now let's plug in what we know. We know the probability that a student is in Algebra 2 given they're in Stats is 80%, which I can plug in as 0.80. I know that the probability a student is in Stats is 0.61, so I plug in those pieces there. I get 0.80 for Algebra 2 given stats, and I can plug in stats down here, which means I'm solving for the numerator. Well, here all I have to do to solve this is, like, imagine this is over 1, cross multiply these, and I'll have my solution. And of course here I'll just be left with the probability that I want. So we cross multiply and I get this. The probability a student is in Algebra 2 and stats is 0.488. And then of course what we need to do here is they said round your answer to the nearest percent. So percent means move the decimal over twice by multiplying by 100. And 48.8% rounded to the nearest percent, well, that's just going to be 49%. Very cool. Let's look at one more problem, and that will be it for this video. Problem number 4 reads as follows. In Mr. Richardson's Algebra 2 class, the probability a student completed the homework is 0.42, or 42%, and the probability they passed the test is 0.6, which is also 60%. If the probability the student passed the test given they completed the homework is 0.85, find the probability that a student passed the test and completed the homework to the nearest percent. First thing I do when I start one of these problems is figure out what we want to find. And I want to find the probability the student passed the test and completed the homework. So I want to find an intersection here of passed and homework. Of course, when we do that, we're still going to use the conditional formula here. So I'm still going to use this formula, and I'm just going to solve again for the numerator, just like I did on the last problem. So I should be given a conditional probability and the probability of the second piece of the condition. That's very important. Well, let's see what they gave us. They told us that the probability the student passed the test is 0.6. They told us that the probability a student completed the homework is 0.42. And hopefully the next one's a conditional. They said the probability the student passed the test given that they completed the homework is 0.85. So it's passed given homework. Passed given homework is 0.85. Well, remember when I plug in here, I have two choices. I can either plug in passed given homework or did the homework given they passed. And here I have to stick with the one I have, and I have passed given homework. So that's going to be what I use. I'm going to do pass given homework. And if I do pass given homework, that means my denominator here is going to have to be homework because they match. So everywhere I see this red A, I'm going to write pass. And everywhere I see the blue B, I'm going to write homework. Let's plug in. There's my translation, and now just plug in. I know that the probability of pass given homework is 0.85, and the probability of homework is 0.42. Notice some of the information in these problems isn't needed. I didn't need to know the probability that they passed. That was just extra information, and the reason they throw that extra information in here is if you had mixed up the order of these two, you would have put the probability of pass on the bottom because it would have showed up second instead of homework. To solve this problem, all you have to do is cross multiply. When I cross multiply, I multiply 0.85 by 0.42, and I get 0.357. They want our answer to the nearest percent, so let's multiply by 100 to make this a percent. And to the nearest percent, well, I'm looking at 35.7, and I have to decide, should I round that 5 up to a 6 or keep it a 5 based on the 7 that follows, and the 7 that follows says rounds it up. So the probability that a student passed the test and completed the homework here is 36%. Well, that's it for our video today. I hope you learned quite a bit about conditional probability and how you can use symbols or symbolic probability to find conditionals. Until next time, have a good one. Bye-bye.